Hi guys, in today's lesson we're going to focus on how you can calculate or how you can approach electric circuit calculations, right? So now it's electric circuits, right? So we have two types of electric circuits. We have a parallel and we have a series. So in order for you to be able to answer any electric circuit calculation, you need to know the properties of each type of connection. Now let's look at the first one. The voltage is the same in our parallel connection, but in our series connection, the voltage is split, right? And then the current is split. And then for the series connection, the current is the same. And then Rp, this is to calculate the resistance of the connection, right? Which is R2 times R1 over R2 plus R1. And then Rs, it's equal to R1 plus R2 plus R3, going on and on, depending on how many resistors that you have. So now when it comes to the parallel connection, this is the formula that I need you to understand and remember. I know that we do have this formula, 1 over R1 plus 1 over R2 plus 1 over R3 and so forth. But the problem with this one, if you are not good with fractions, then this method, it's going to be a problem. Whether they just gave you 2 resistors or they gave you more than 2 resistors. But with this method, it doesn't matter how many resistors you are given. You can still calculate, you can still calculate what the resistance is without actually sweating, right? Now I'm going to show you how you can use this. So now let's first look at the current is split part, right? Just to explain that basic. So now let's say that we have a connection in parallel like this. Now I1, I2 and I3, right? Now looking at this, if you were asked to calculate the current, how are you going to approach this? So now in order for you to calculate the current within a parallel connection, you need the voltage within the parallel connection, because we know that the voltage is the same. So if the voltage is the same throughout the parallel connection, that means that you can use the voltage along with the given resistor in order for you to find what the current is, right? So these three current, if you add them, they are supposed to give you the exact same value as the ammeter reading. Now that means that when you add all of these, they are supposed to give you the total current within the circuit. If their values aren't the same, then it means your calculation is wrong. That's something that you need to take into account. So if we do have the voltage, right, let's say that we have a voltage called V1, right? If we have this voltage, now they ask to calculate the current. How are we going to do this, right? We would say that I1 is equal to V1 over R1. So this would give us the first current, right? I2 is equal to V1 over R2. Second current, I3, sorry about that, I3 is equal to V1 over R3. So can you see that the voltage is the same, right? Through the calculation, the voltage is exactly the same. It does not change. The only thing that changes is our resistor. So this is how you can calculate the current within the parallel connection. So now when it comes to the series connection, if you're looking for the voltage, then you can say Vt is equal to the sum of the voltage within the circuit. So that means that V1 plus V2 plus blah blah, depending on how many voltage that you are given within the question. So now I'm going to show you how you can apply this method when you have more than 2 resistors within the circuit, right? All right, now let's look at how we can approach this, right? Now let's say that you have a resistor, 3 resistors like this. The drawing is not really good, but just bear with me, right? So you have this, so let's just give them values and say that okay, this one I can say that is 2 ohms, this one we can say that is 4 ohms, and this one we can say that is 7 ohms, right? Now you are asked to calculate the resistance of the connection, right? How would you do this? Now remember, I told you that focus on this formula, R2 times R1 over R2 plus R1, because this formula, it's simple, right? All you have to do is substitution. But when you are using this one, Rp is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on, then you must know how to simplify fractions, because if you do not know, then this is going to give you a huge headache, right? So now this is just to make things easy for you. Now let's look at how we can apply this, right? So we're going to focus on the first 2 resistors, the 2 ohms and the 4 ohms, right? So now that's going to be 2 times 4, 2 plus 4, sorry about the order, you can say 4 times 2, but still the same thing anyway. All right, so now this 4 times 2, this would give us what? 8, and then 4 plus 2, that's going to give us a 6. So now that's the value that the first 2 resistors are giving us, right? So you're going to continue from this. This becomes your new R1, right? But you do not start a new calculation, you just continue from this and you say equal to, right? You reapply the equation from this step. Now this means that you're going to say 8 over 6 times 7 over 8 over 6 plus 7. Now this would mean that it's 8 divided by 6. It's going to give you that times 7. Then you have 9 over 3 divided by 8 divided by 6 plus 7. That's going to give you 8,333. Now if you divide this, divided by 8,333, that's going to give you 1,120 ohms. That's your RP. So this is basically how you can approach the parallel connection if you have more than 2 resistors. So you see, you still apply this formula, right? Doesn't matter how many resistors you are given, you're going to focus on the first 2, right? When you have the value, then it becomes your new R1. Then you're going to use the last resistor that you did not use as the new R2. Then you can calculate from there. So this is what the method gave us. So you will still find the same answer even if you were using this method, just that this one is simple, right? You just substitute, punching in the calculator the values and all that. So this one, it's a simpler method. You do not have to be a master of fractions. Even if you do have problems in fractions, you can still answer this type of calculations. But with this one, you must know how to calculate your fractions, right? Now let's continue and look at an example, right? Okay, so we have this circuit, right? So they gave us 24 volts. They gave us 24 volts. They gave us 3 resistors, an ammeter, 2 of them, ammeter readings, and then what else? Yes, the total ammeter reading, right? So now this one would tell us the current within the circuit. This 2 would tell us the current within this resistor, and this one would tell us the current within this resistor. Now let's look at the question. The first question says calculate RT. Now what does the RT stand for? That's the total current, the total resistance within the circuit, right? So with that being said, how do we calculate the total resistance within the circuit? So your RT, it's going to be Rp plus Rs. So you need Rp, you need Rs. So now the first thing that we need to calculate is our Rp, right? The connection, the parallel connection. So we have 8 and 8, right? Okay, so Rp is equal to R2, R1. Remember our equation, right? Simple to use. So it's 8 times 8 divided by 8 plus 8. It's equal to 8 times 8. That's going to give you 64. And then 8 plus 8, that's going to give you a 16, right? So 64 divided by 16, that's going to give you a 4. So that's your Rp. Rp, right? Therefore, your Rp is 4. Therefore, your total resistance within the circuit, going to say 4 plus 8, right? Because this 8 is from this series connection. Can you see that this one is connected in series? Therefore, we must look at it in that manner, right? So we have calculated this part. We do have this part as well. Now, when you add them, that's going to give you 12 ohms. That's your total resistance within the circuit. That's how we calculate. You need the Rp connection, the resistance of the parallel connection, and also for the series connection, you add them, then they're supposed to give you the total resistance within the circuit. The next calculation says calculate the readings on V1. V1. Now, this is our V1, right? So now they're looking for that. So how can we calculate that? Interesting. So we can see that this connection is in, this is a series connection, right? And in a series connection, the properties are, the first one, the voltage is split, okay, but we do not have any other voltage, so we can't use that. Number 2, the current is the same, okay. So do we have the current? No, we don't. But can we calculate the current? Yes, we can. So IT, it's equal to VT over RT. So now that means that you're going to say 24 divided by, what was our, oh yes, RT was our 12, right? So 24 divided by 12, that's going to give you a 2 amperes. And that's your current. So since we have the current, we can then calculate what our V1 is by using the property of the series connection that says that the current is the same, right? So IT is equal to V1 over R1. So it's 2, it's equal to V1 over 8. Now we multiply both sides by 8. These will cancel out. Therefore, V1 is equal to 8 times 2. Now that's going to give you a 16, right? So that's your voltage within V1. Right, so now we have that. So the next question, the readings on A1 and A2. Okay. So if we look at this parallel connection, we can see that we have the resistor, right? But there's something missing. We do not have the voltage within this connection. So how can we find the voltage within this connection? Remember, the voltage in a parallel connection is the same. That's the property for the parallel circuit. The voltage is the same. So we need the voltage in order for us to calculate what the ammeter reading is. So now, in order for us to find the voltage, we're going to use the sum of the voltage within the circuit. Now, this means that you're going to say VT, it's equal to V1 plus V2, right? So VT, we do have it, it's 24, V1, it's 16 plus V2. So if you shift this to the other side, the sign will change. Therefore, V2 is equal to 24 minus 16. Therefore, 24 minus 16, that's going to give you an 8 volt, right? So now we have our voltage. Therefore, we can calculate what the current is. So now I1, it's equal to, the voltage, right? So we can call that V2. It's over R2. It's equal to, the voltage is 8, the current is 8, and the resistance is 8. That's 1 amperes. Now I2, it's equal to V2 over R3, right? 8 over 8, that's going to be 1 amperes. So can you see that if you do add both of this, they would give you 2 amperes, which is the same as our I total. So now that means that our calculation is correct. So that's why it's very important for you to understand the properties of the connection, because if you do not understand the properties of the connection, then you're going to have problems when you answer it. Right, now let's look at the last question. Right, now on this one, okay, we're not given, okay, we're given the voltage for, we have 2 resistors connected in parallel, we have 1 connected in series, right? Now we're supposed to calculate what? Let's see, RP, okay, the connection in parallel. Then we're supposed to calculate V1 and V2. So we're supposed to calculate this and this, right? Now looking at the first question, they're asking us to calculate RP. So now that's simple. We just have the resistors, so we're going to plug them in. So RP is equal to R2 times R1 over R2 plus R1. That's equal to 2 times 6 over 2 plus 6. It's equal to 2 times 6. It's 12 over 6, 7, 8. Sorry. 6, 7, 8. 12 divided by 8. That's 1.5. 1.5 ohms. That's your RP. So we have answered the first question. Now the next question says calculate the reading on V1 and V2. Now the interesting part of this is that we have RP. So if we have RP, I can convert this connection to become a series connection. How do I do that? Interesting, right? So you're going to say this. Let me just try to redraw like this, right? Then we have this connection 1, and then we have this connection, we have this connection, we have our V1 there, and then this is our V2, then this is our 4 volts, which is given, right? And now this is going to be your RP. This will be a 4 ohms, right? So it's 1.5 here. So can you see that now it becomes a what? A series connection. It becomes easy for me to apply the properties because now I know that it's a series connection. So within a series connection, right? Now we are supposed to find V1 and V2. Now how can we find that, right? So looking at the connection, what are the properties? The voltage is split, right? So we only have 1 voltage, so we can't use that. Number 2, the current is the same throughout. So if I have the current, right, within the circuit, what can I calculate? If I have the current, I can calculate my V2. Then I can use the first property, which says that the voltage is split. Therefore, it's going to be the sum of the voltage for me to find V1. So now let's just use this. Say I total, it's equal to 4 volts divided by your RP was what? It's 1.5. So 4 divided by 1.5, that's going to give you a 2,6666 amperes. So I'm not converting this, I'm just going to write it as it is so that it does not affect my final answer, right? So now from this I can find the voltage. So it's going to be I total, it's equal to the voltage V2 divided by my R2, right? So now this, it's 2,6666, it's equal to V2 divided by, actually, sorry, it's 4. It's 4 here. No, what am I doing? It's V2 over 4, right? Multiplied both sides by 4. This will cancel out. Therefore, your V2, it's equal to 4 times 2,6666. Therefore, this would give you what? Times 4. It's 10,6666 volts. right? Now, in order for you to find V1, we can use the sum of voltage. So we can see that since this voltage reading is within the battery, right? You can see that it's a battery. So this, it's called a cell. If it's more than one, more than two, whatsoever, then it's a battery, right? It's a battery, right? All right, so now we can say V1 is equal to V2 plus the 4 volts, right? Now this is going to be 10,666 plus 4. That's going to give you a 14,666. If we round this off to one decimal place, then it would give you 15 volts. That would be our V1. So that's basically how you can calculate electric circuits. Just understand the properties, ensure that you understand the properties, and before you write, you must ask yourself, what can I do, right? So these are the properties. It's important for you to remember this. The voltage is the same, current is split, voltage is split, current is the same. That's all that you need to remember. Then you can answer any question that's related to electric circuits. So thanks for watching. Please do like and subscribe to the channel. If you have any questions, you can leave your question on the comment section. I will text you back, right? See you next time. Bye.